Okay, so today we're going to talk about acids and bases again, but we're going to talk about neutralization. Okay, so the generic form of the equation that we're going to write here in generic neutralization equation, we're going to write it in words, and then I'm going to do a couple of examples. So it's going to be acid plus base yields salt plus water. Okay, so the generic neutralization equation is that if you take an acid and a base and you add them together, you're going to make something called a salt and water. Now, it's not always NaCl, it's not always table salt, it's just called a salt because it's like an ionic compound. Okay, so let me give you an example of something from real life. So we have stomach acid, which is actually in your stomach, and this is going to be hydrochloric acid, so that's going to be HCl. And then when I add Tums, if I have stomach acid and it starts to go up my esophagus and I feel heartburn or indigestion, okay, it's when the stomach acid is coming up into your esophagus and you kind of feel it and it burns. So what we're going to do is we're going to neutralize it. So we do that by adding a base, because remember, acids and bases are sort of opposites. If you remember from the property stuff that we talked about the other day on the reading from that like textbook looking thing. So when I add a Tums is calcium hydroxide. So that's going to be CaOH2. The reason why this has a 2 over here, this is plus 1 minus 1. So when I crisscross, it's 1 and 1. Here, calcium from the periodic table is a plus 2. So then that's the 2 on the outside. OH is from your polyatomic chart. It's a minus 1. And that's where the formula comes from. Okay, so that's just kind of what that looks like. All right, and then it's going to make something called a salt. And then my other thing is going to be water. So to make your salt, what you're going to do, okay, since all your acids are going to start here with H, is you're going to take whatever part was of your base, whatever positive part of your base is, which is going to be the first listed thing, and we're going to pair it with the negative thing from the acid. So I'm going to put Ca and Cl together. So I have Ca and Cl. Now, calcium, a reminder, let me grab a periodic table for you and a polyatomic chart. All right, so calcium, all right, so let's look at that. I'm going to use this white one. Calcium is in group 2 of the periodic table, so the charge is plus 2. Chlorine has a charge of negative 1. So then when I crisscross, it's going to be CaCl2. Okay, just to show you where this one came from, I'm going to use the polyatomic chart. I feel like you need that visual. So we have calcium, again, was a plus 2 over here. And then OH came from the polyatomic chart, which we haven't looked at in a little while. But OH is right here. The charge is negative 1. And so when I crisscross a 1 and a 2, that's what I get there. Hydrogen and chlorine. So hydrogen has a charge of plus 1. Chlorine has a charge of negative 1. So this is plus 1 and this is minus 1. And so when I crisscross, that's what I get. All right, the other thing that I haven't used, so let me kind of show you what I'm talking about. So to make the salt, we took the positive thing here and we paired it with the negative thing here. Remember, the positive one has to be listed first. It will always start here with a metal, okay? Same thing here. This one will always start with a metal, but you'll be given the left-hand side. So you're going to be making this positive thing with this negative thing, CaCl2 in this case, that's our salt. And then our water is going to be whatever's left over. Well, the only things we haven't used yet are H and OH. Well, H and OH can be written as HOH. That's the same thing as H2O because there's 2 H's and an O. Okay, but I think it's better to write it as HOH because we're going to get ready to balance this in just a second. All right, so this is water. HOH is the same thing as H2O, but I want you to write it like this because we're going to balance it and you're going to have an OH on this side. All right, so charges-wise, we have H, which is a positive 1. And then from our polyatomic chart, let me write the plus 1. From our polyatomic chart, we have OH again, which is negative 1. So when I have positive 1 and minus 1, they basically cancel out, and it's just HOH. Okay, but now we're going to balance it. Grab a different color there. Okay, so it doesn't really matter which ones you start with, but it's probably good to start with your metals. So there's one metal here, one metal on the right. We're good. My calciums are good. Let's look at our non-metals. That's going to be, or polyatomics next, sorry. So we have 2 OHs here and only 1 over here. So we're going to add a 2 in front. That's 2 OHs, 2 OHs. Okay, now let's look at our chlorines. We have 1 Cl on the left and 2 on the right. So I'm going to put a 2 in front here. So 2 chlorines, 2 chlorines, 2 OHs, 2 OHs, 1 Ca, 1 Ca. So everything is balanced, and this is going to be a 1, and that's going to be a 1. Okay, so again, this is an acid. I know it's an acid. It starts with H. This is a base. I know it's a base. It has OH. That's what we talked about with basic properties. So acid and base make something called a salt, using the positive part of the base and the negative end of the acid, and then water is what's left over. The reason it's called neutralization, it's related to pH. So the pH scale, in case you didn't know, goes from 0 to 14, and exactly in the middle is 7. Okay, so this water has a pH of 7, okay, and that is what we call neutral. Okay, that's our neutral pH. Because it produces water, it neutralizes the stomach acid. So when I have my heartburn and I add my Tums, what I get is some kind of salt, which doesn't really change the pH at all, and then I have water. So what I did is I didn't make it doesn't burn anymore because now I made water, which has a neutral pH of 7. Acids have a pH of 0 to 6. Bases have a pH of 8 to 14. Exactly 7 in the middle is our neutral. It's our water. That's why it's called neutralization. Okay, let's try another one. So we have HNO3 plus CaOH2, and we want to figure out what they make. Okay, so it's going to make a salt and water. So we're going to make our salt first. I'm going to use the same colors. So we have our positive one here and our negative one here. So I'm going to add those things together. The positive one has to come first. So I'm going to have calcium. We know from the periodic table that calcium has a +2 charge. And then we're going to put it with NO3. We know it's going to need parentheses. All right, let's look up our charge of NO3 on the polyatomic chart. NO3 is nitrate. The charge is -1. So then when I crisscross, this is a 1, and this over here is a 2. So it's Ca parentheses NO3 2. Remember, anything from this polyatomic chart should go in parentheses. All right, and so we used that, and then the thing that I haven't used is my orange, my H and my OH. The last product is always going to be HOH, guys. It's always going to be water. So that's really, really nice and really, really simple. Okay, and then now we can balance it. And we already know that the charge of hydrogen, just to remind you, we already know the charge of hydrogen is +1. We know the charge of the hydroxide, we've now looked it up 3 times, is -1. So this is +1, and this is -1. So when I crisscross, we don't write anything. They cancel. All right, so let's see if we can balance this. So we have 1 Ca on the right. All right, our polyatomics. We have 1 NO3 here. Remember, this is all one thing. Okay, over here, I have 2. So I need to put a 2 in front. All right, so 2 NO3s, 2 NO3s. Let's look at our OHs. Here I have 2 OHs. Over here I only have 1, so I'm going to put a 2. 2 OHs, 2 OHs. All right, but now let's look at our H's. That's 2 H's, 2 H's now, so that part's balanced. 1 Ca, 1 Ca, everything is good. This is a 1, and this is a 1. Okay, let's try one more. All right, so on your assignment, you're going to be labeling the acid, the base, the salt, and the water after you make it. So let's do it. On this one, it was already labeled for us, but let's label them here. So since this one starts with H, this one's going to be my acid. Since this one ends in OH, that's going to be my base. This is my salt, and then of course we know HOH is water. So a salt is just an ionic compound, all right, with a positive one listed first, then the negative one. Positive, negative. All right, so don't forget to come back and label. I'm going to do it on this one too. All right, so let's look at our things. All right, so we have NaOH plus H2S yields. So we're going to do the same thing we've been doing. Now, I did this one on purpose because not all of them are in the order of acid plus base yields salt plus water. You got to pay attention to what you have. All right, if something ends in OH, that means it is a base. If something starts with H, that means it's an acid. So that part doesn't matter. It can be in whatever order. You're still going to make a salt and water. Okay, so you can always keep that in the same order just to keep it simple. Okay, so we already know that one of them, I already know I'm going to have H and OH together. So I already know that this is going to be HOH. because I said every single one of these is going to end in water, HOH. All right? So now we got to see what's left over. I haven't used S, and I haven't used Na. So which one of these, the Na or the S, is positive? Because that's what has to be listed first. Well, let's check out their charges. If I looked on the periodic table and I found Na, I would see that it has a +1 charge. So this is +1. And then OH, we've looked up 3 times now, is -1. All right, H, we know, is +1 from the periodic table. And then let's look at S. S is over here, and the charge is -2. So to make our salt, we have to start with the +1. So that's going to be our Na. We just looked up the charge, it's +1. And then our S, we just looked up the charge, is -2. So when I crisscross, it's going to be Na2S. Okay, you don't have to show the charges. I'm just showing you how to do it. And then don't forget to come back and label. Your acid and your base can be in a different order. Okay, you just got to pay attention. All the acids are going to start with H. All the bases are going to end in OH. So you're going to have to pay attention to see which ones you have first. Like this one, it does not start with an acid. It ends in OH. That's a base. Okay, make sure you go back and balance. That's the last thing we're going to do since we already labeled it. All right, so we have 1 Na, 2 NAs here. So I'm going to go ahead and put a 2 in front. All right, I have 2 OHs now because of this 2 in front. Over here, I only have 1, so that's going to be a 2. 2 OHs. All right, let's look at our H's. There's 2 here on the left, 2 now on the right. Remember, OH is separate, so you don't count it as part of the H's. All right, I have 1 S here, 1 S there, so that means this is a 1 and this is a 1. Okay, you're going to get a lot, and a lot of them are going to have a 2 for the water. Not all of them, but a lot of them are going to have a 2 for the water, so that's pretty common. Just to balance them. All right, so the directions here, it's just these right here. You're going to write a balanced equation for these neutralization reactions. Remember, it's called neutralization because it makes water, which has a pH of 7. It's exactly in the middle of the pH scale, which is 0 to 14. Okay, acids are 0 to 6, bases are 8 to 14. Exactly 7 is neutral, and that's why it's called neutralization. It makes water. Okay, it says label the acid, base, water, and salt for each of them. And then you're going to crisscross, just like I showed you in the 2 examples. So it's just these questions here, these 8 questions. It's not that many, but if you do have any questions, please feel free to email me or contact me on Google Voice.